Hello and welcome to the Elektor Engineering Insights show. I'm your host, Stuart Cording. Now, we spent a week at the Electronica 2022 exhibition in Munich from the 15th to the 18th of November, and it was absolutely heaving with over 2,100 exhibitors spread across 14 halls. It was packed with 70,000 visitors, many of whom come from abroad to see the show. The place was filled to the rafters with electronics, semiconductors, system providers, distributors and startups, all showing the latest technology that they had to offer. I walked around so that you don't have to, and this is what happened. Now, there's plenty of innovation going on at Electronica 2022 at the onsemi stand. They've got the Mercedes here that was capable of driving 1,000 kilometers for the first time ever as an electric vehicle. And that machine is supported by SiC MOSFET technology from the team here. We've also been talking about the DC-DC converters and inverters that are based upon that technology, and also some top-cooled MOSFETs, which make it much easier to dissipate the heat out of those switching applications. I also caught up with Jared and found out more about their dual sensor inductive rotary solution, which gives you much higher accuracy at higher RPMs than previous types of inductive sensor. So hi Jared, lovely to meet you here at the onsemi stand, Electronica 2022. It's been so much fun, I'm really excited.
Yeah, it has been fun, thank you.
So I'm here, and we were looking earlier at your rotary sensors, and you've been developing something new as an inductive sensor, which is quite advanced.
Yeah, we call it a dual inductive approach. The product is the NCS 32100, and that dual inductive approach allows us to get an absolute position and allows us to get higher accuracy than traditional inductive solutions. We have multiple coils, we get more information that way. Inductive coils, they couple across the entire area. It's not a single point like optical or magnetic, and so that's one way we get more accuracy out of the same area.
So what's the challenge with the single inductive approach?
Well, one thing is you can't get absolute position, right? You can only get incremental position, right? And it's just less information. Dual inductive allows more information and absolute position. So you can power off the sensor, power back on, it knows exactly where it is, it provides absolute position without having to move the sensor at all.
And my understanding is when it comes to these sort of positioning sensors, inductive has always been less accurate than alternative. So where does the dual
inductive sits on the traditional inductive techniques, has been a little bit lower accuracy, lower speed, probably comparable to magnetic solutions traditionally. Our goal for this product was to go head-to-head with higher precision optical solutions. So we're talking 50 arc seconds, and we've done it. So our solution is 50 arc seconds, 6,000 RPMs at that accuracy. We can go at faster speeds as well, up to 100,000 RPMs at a reduced accuracy. So yeah, it's right there, right in the wheelhouse of optical solutions. We're going to go head to head, and maybe we'll talk about it now. The BOM is reduced, right? So an optical solution has maybe, we've seen some that have 100 parts on multiple boards. 2 boards, you have optics on one side, receivers on the other, you have to get the expensive disc. So our total BOM is 12 parts.
Wow.
That's only 2 active components, our part and a driver. That's it.
Now, typically these types of sensors have an analog sine wave output, maybe that has to be then processed by another processor. Is that the case with yours?
No. In fact, we realized that an analog output, you have to have circuitry after that to process. You got to have an ADC, you got to have some DSP and a processor to calculate that information from the analog output to an actual position, to an actual velocity. We've integrated all of that into the NCS 32100. So what that means is customers can grab that part, drop it in place, like I said, a BOM of 12, and it's ready to go. We have default firmware that we program in the production environment, so it's ready to go with that default setting.
And does that mean it's also possible to develop custom firmware? And is that something you help customers
Yeah,
with, or
yeah.
do they do it themselves?
Yeah, that's an option as well. If customers want to make a different size position sensor, a bigger diameter, smaller diameter, they want to do a custom interface or some custom filtering or other, bells and whistles they want to add to it, there is space in that processor to do their own firmware. They can modify our default firmware with customization.
Now, calibration of these sensors can be a challenge. It can take quite some time to match everything up. How does it work with your solution?
There's some sensors out there that take a very long time, like multiple minutes, 1 or 2 minutes to calibrate. So because we have the processor inside of the NCS 32100, we have all of the calibration routines already in the firmware. So the calibration routine is very simple. You simply spin the rotor somewhere between 100 and 1,000 RPMs. It doesn't need to be precise. It can be, imprecise throughout that period. And calibration takes 2 seconds. That's all it takes. So super fast. So production environment, in a customer's line is going to be super fast and easy.
So when it comes to customers, what are the sort of applications where these sensors are going to find their sort of best and ideal use case?
Yeah, so these applications would be precision, high accuracy, position sensing, so robot arms, cobot arms, slip detectors in wheels, anywhere you need accurate servo drive control, servo loops in industrial automation. That's mostly where we're going to see the interest. If you're using an optical sensor with 50, 100 arcsec accuracy, come check us out. I think we can be a better solution, more robust, lower BOM. It's a really good option.
So, hearing that we've got this much improved inductive sensor with that higher accuracy at high rotational speeds, I'm sure people would want to be able to try it out. What do you offer in terms of a development or evaluation solution?
Yeah, good question. So we are fully released. We launched here at Electronica, and we now have evaluation boards ready to ship out that hook very seamlessly to our Strata Developer Studio. You download the software, plug it in, and it auto-recognizes the evaluation kit. It's easy to evaluate it right there. You can spin the rotor, change some functionality around, some bells and whistles in that program. But also the evaluation system, we designed it so the end part breaks off, just the sensor itself, so customers can start to prototype that in their system and put it right in.
That sounds like a great idea. Well, thank you ever so much, Jared, for those insights on the inductive sensor. We wish you a great show.
Well, thank you very much. I appreciate it. Have a great day.
Also at the onsemi stand were new MOSFET devices sporting an innovative package design. Effective heat removal is a critical challenge in power applications, and MOSFETs typically dissipate through the underside into the PCB. onsemi's new TC-Pack 57 top cool packaging allows heat to dissipate directly to a heatsink or the application's housing. This eliminates the PCB from the thermal path, leaving more room on the board and delivering cost savings. Just 5x7mm, these MOSFETs are AEC-Q 101 qualified and PPAP capable. The initial portfolio can operate at junction temperatures of 175 degrees Celsius, and they target automotive applications such as power steering and pumps. But what caught most people's eyes was the VISION EQXX, the all-electric Mercedes-Benz that completed a 1,200 km trip from Germany to England on a single charge. Part of this feat is attributed to the traction inverter featuring onsemi's VE-Trac SiC modules, helping ensure that 95% of the energy from the 100 kWh battery reaches the wheels. For reference, internal combustion engines only achieve 30%. Simon Keaton, Executive Vice President and General Manager for Power Solutions Group at onsemi, said, "The high efficiency of our SiC solutions allow customers to avoid trade-offs between the cost of the battery and the range of the vehicle. One of onsemi's differentiating factors is packaging expertise, enabling improved heat dissipation and higher power output that delivers a smaller footprint than the closest competitor in silicon carbide."
Now, every application needs power of some kind, and there's always that question to make or to buy. Now here at TDK-Lambda, they have a modular solution, which means you can get a lot of flexibility without having to go through all the challenges of designing and qualifying the power supply yourself. I spoke to Chris to find out more about Mu. So hi Chris, here we are at the TDK-Lambda stand, and it's Electronica 2020, which means there's always some new technology to share with us.
Yep.
What have you been working on?
Well, thanks Stuart. First of all, it's brilliant to be here. It's nice to see all our customers and colleagues as well.
It's been 4 years, hasn't it?
Oh.
It's been such a long time.
It's a relief
Yes.
as well. It feels so much more natural as well. I think sometimes we have too many Teams calls, but this is really refreshing. But what's new? So we have a new product. So it's a modular product. So it's a power supply. So it's new. So this is the fella here. So it's quite a small power supply. So TDK-Lambda, we actually invented the modular format back in 1979. I was just a small boy. I was 9. Okay, but
I wasn't much. I was a little bit younger, but not much.
But the modular format is really useful for customers. It has really good flexibility. So the module is actually in 2 stages. We have the high voltage converter or rectifier, where we take the mains input, we convert it to a relatively high voltage DC, and then we use multiple DC to DC converters on the output, which our customers can choose. So they can choose say a 5, 12, 24, 48 volt converter. But also those DC-DC converters are adjustable. So you can adjust those up to about 54 volts. And even more flexibility, you can connect them in parallel to increase the power, or you can connect them in series and increase the voltage. So it really is an easy way to install power and actually optimize it in a standard format to the application as well.
So the modular concept is very clever with the rectifier, the power factor conversion at the front. How many modules though can be fitted into this type of design? So it's a 1U design, isn't it?
It's a 1U design. So I'm not sure if you can see that, but we have 4 modules, so you can see them here. So these are the outputs, but also we have an option board which allows us to have an additional voltage out. So we have 4 output voltages plus an auxiliary voltage as well for housekeeping sort of systems as well.
Now, when we talk about power and obviously the current climate we have with energy issues being delivery of energy, gas, electricity prices rising, efficiency is the number one thing, and efficiency in power supplies is linked back to heat.
Yes.
So what innovations are there in this in order to make sure cooling is working correctly and we don't get too much heat inside running at full tilt?
And Stuart, that's really a good point, because heat is a killer for a power supply. And every 10 degrees C rise we see inside, you halve the life of the power supply. So you raise it 20 degrees, you really are reducing the lifetime. So what we've done is we've done quite clever design. So for the first time for modular, we're using an aluminium chassis. So this is aluminium. And we also have here, we use very thin packed semiconductors for our switches. These are actually on the bottom of our PCB, and we use a thermopad to actually mate those down to the base of the aluminium chassis. Now that's the converter. On the DC to DCs, we also have individual heat sinks on those, and they mate down again onto the chassis. So we use the aluminium as effectively a massive heat sink. Now, that's one part of it. It's almost like a hybrid system, so we can take heat away, but there's still some heat inside. So to handle that, we also have a small fan. Now, a small fan is normally quite annoying. It's noisy, it's whiny, but we manage this fan quite nicely. So what we do is we don't run it at full speed. We have a small airflow to keep the individual converter and the modules cool, but we temperature monitor each individual DC-DC converter and also the main rectifier as well. So if any one of these parts of the systems require additional cooling, they can call for that. And then the fan will spin up, deliver more airflow. If that's not enough, it will request more, so you deliver more fan. And that's where this actually has a patent. So we have a patent pending where it allows us to communicate between the high voltage side and the low voltage side. So it's quite a special design. But why is that important? So this is a medical power supply, and it sits very close to patients, or could sit very close, and a whining fan is not only annoying, but it could also be damaging to patients if it's done there for a long time.
Yep.
So we have to manage audible noise. So we can keep this down to around about 36 dB, which is amazingly quiet for an 800 watt power supply. So, and once you put this power supply into a system, that 36 dB is also reduced and muffled by the overall system as well.
Now, you've mentioned medical there as a target application. What other types of customers have you got, and what are they building, and why are they choosing this type of modular approach?
Okay, so our customers are varied. So we build it to the highest standards for medical. So that's obviously, we care for the medical systems. It's a high priority load for us, and we need to support that with reliable products and also for long life. But the same is required for industrial applications as well. If you have a factory running 24/7 and say for instance in an automotive or even a chemical plant, you need to run those, keep those systems running all the time, and you need that reliability. And also you need that flexibility of voltage rails you can actually offer. So a modular offers that. But you can also go to automotive for ATE. Again, you can switch the outputs of the individual 4 outputs using a PM bus. Okay, you can turn those on and off as you require. So for an ATE system, this is actually quite a nice feature as well.
Now, where are these products actually manufactured?
So they're manufactured in the UK. It's designed in the UK. We did all the validation again in the UK. In fact, we also we're actually expanding our factory because of new. This is part of the business plan. So we're putting £11 million worth of investment. We're increasing our floor space for production equipment by 50%. So it's a really good news story for the UK.
And another challenge around products which have to fulfill high reliability requirements and quality requirements like medical is the supply chain, making sure that the capacitors, inductors, resistors and the ICs being used are top quality and from approved suppliers. How do you keep track of what's coming into the factory?
Okay, really good question. So we invested a number of years ago in a design and validation test lab. So this is full EMC chambers plus X-ray equipment. Also we can stress components. So every component, even before it hits the board, we're evaluating whether it's actually meeting the specification. And we don't just measure one. Okay, if we have it on a reel, we'll measure components further on down the reel, just in case there's a difference between the whole system. So we can check that. Even on silicon, and particularly over the last 2 years where there's been challenges in sourcing components, with our design and validation lab, we're able to take products from not our normal sort of suppliers, but we can actually take those components and validate that they are real, actual components. They're not copies or anything like that. We can do X-ray analysis. We can do all the full functional stress tests on them as well.
Well, I think the modular approach is very, very interesting, and obviously the patent pending cooling process is a great addition to this sort of modular approach. Thank you very much for taking the time to introduce you to us, Chris.
Stuart, thanks very much. It's been a pleasure.
Now, a lot of the hype in the semiconductor industry is around the highly integrated chips, but we also need the discrete parts too to make highly efficient power conversion technology. I'm here to talk to Nexperia, Dirk, to find out what they've been doing in the space with some rectifier diodes for photovoltaic and electric vehicle chargers, and also an interesting battery booster technology for coin cells. So hi Dirk, lovely to see you here. We're back at Electronica again after a 4-year pause at the Nexperia stand. What's been going on over the last 4 years in terms of business development at Nexperia?
As you are, exciting to be here. Many new products are ongoing, many customers engagement are ongoing. So from Nexperia perspective, we expanding in our product portfolio. We go strongly in the power discrete area, where we have an example like gallium nitride, but also here we announced that we go into silicon carbide rectifiers the next years to go. We also expand into IGBTs and more power module applications. On the other hand, we also want to grow into the analog IC area, where we, for example, have all voltage translators in, but we also go into load switches and this kind of applications. One very exciting one we can speak later on as well is on the battery booster for example, where we optimize the power of the battery.
Now, one of the challenges at the minute is obviously designing all those products, and I understand that you're trying to expand also the workforce in order to address those new markets.
That's true. We are in a global world, and we need to attract the talents to support the growth and to work together. So in the past, we always have our design centers very closely to the factories. In addition to that, we are opening new design centers. And it's a proof point what we did in the last 2 years is we opened a design center in Malaysia 2 years ago. Last year we opened a design center in Shanghai, our China design center. This year we opened in Dallas a design center, and more to come. So next year we're targeting an R&D design center here in Munich, where already Nexperia has the sales and marketing center for Europe.
Now, there's a huge number of battery-powered applications today. IoT sensors are one of those areas where we're always talking about batteries, and it's about battery life and making sure we get as many of those electrons out of the coin cell as possible. You've been working on a battery booster chip, so tell us a little bit more about the advantages that brings to developers and the sensors and applications of building.
Yeah, the battery booster is really something new for Nexperia. It's really portfolio expansion. So this is focusing on low power. So we are targeting a battery booster for coin cell battery applications. That battery booster is operating between 1.8 and 3.2 volt and boosting up to 100 milliamp to 200 milliamp. It's an intrinsic capacitor, but we can support peak power by boosting it then in that time. But we also can reduce the average power. With that new technology in-house, we can expand the battery lifetime of a coin cell by 5 to 10 times.
We're also in the middle of an energy crisis. We're trying to use every electron as efficiently as possible. In the space of power conversion, for example, as well, it's really important to make sure those diodes are really allowing as much efficiency to be achieved in switching power supplies as possible. What have you been doing in that space?
Many things. Energy efficiency is all over around. One example, what we just launched, is a rectifier, silicon-based rectifier in 650 volt, and a new package technology, a clip-on flat power technology. We call it CFP for clip-on flat power. That has the advantage that the forward voltage is as low as 1.2 volt. We are targeting applications on onboard charging for a 7.2 kilowatt single phase inverter, as well as we're targeting applications for photovoltaic inverters, single phase inverter. Efficiency becomes crucial, and Nexperia contributing to the power efficiency.
Well, thank you for giving that update about the technology that's being developed and here on the show today, and we look forward to seeing what comes in the next 12 months.
It was a pleasure. Thank you very much, Stuart. Thank you.
As the automotive industry transitions from combustion engines to electric motors, they need new technology to be able to drive them efficiently. Now, the S32K39 from NXP is there, providing not only a new solution for driving those motors, but also supports the software-defined vehicle concept and the zonal architectures that are being introduced. I caught up with Brian Carlson to find out more. Hi Brian, it's great to be here at Electronica 2022 on the NXP stand. Now, when I last saw you, we were at Embedded World, and you just launched the S32Z and E, and those are sort of huge processors targeting the automotive industry, and this move and change to zonal architectures and software-defined vehicles. And you're back again now a few months later with another innovation.
Yeah, every few months we come to Germany with more innovations. So here we are at Electronica. Today we're building on that story. So as you indicated, we have S32Z, S32E, and I call that really the brain of the EV. What we're doing here is now how do we extend that for the brain of the motor? And they work closely together actually. We support both of them to be able to support 1, 2, 3, or 4 motors in a vehicle, and that really is attractive to EVs for scalability. So it's a great story to build upon our success with the S32Z and E.
So take us a little bit around how that motor solution looks from a silicon perspective. We've got the processor, and we've got some traction, some gate controllers as well for the power side.
Yes, definitely. So this is the highest device in our new is an S32K39. It's the highest performance point. It has multiple Cortex ARM7s. There's 2 Cortex ARM7s that are always locked up. We use that for safety processing. And there are 2 others that are split locked, meaning they can be locked together also, or they can be split separately. So you can have 2 fully locked, or 3 cores, 2 unlocked and a locked. So that's the ARM processing, which is significant. 320 megahertz Cortex ARM7s. That gives a lot of performance just by itself. In addition to that, and what's really important for this device, the S32K39, is the addition of 2 dedicated motor control coprocessors. And those also run at 320 megahertz, and that gives us the magic to be able to do these things at such a high frequency. We also have a DSP, a 4-thread DSP that can do digital filtering, anomaly detection, machine learning. It provides a lot of flexibility to help offload and integrate analog functionality within the chip and process it digitally. So from a processing point of view, a lot of processing going on. Now, it's more than just processing. I talked about analog. So we can support up to 73 channels of analog. 4 of those are Sigma Delta, which is really high precision that we use for resolver, I'll talk about later. We also integrate a sine wave generator so we can excite the resolver. Again, I'll talk about that later. A lot of analog components are integrated into this chip to help reduce cost and to provide a better overall system solution. This also has built-in security, our hardware security engine, which is common across the S32 family. The beauty of that is that it goes beyond what typically is in the industry, very high performance, but also supports the asymmetric cryptos, public key infrastructure. We just announced yesterday at SCAR about how this hardware security engine can even extend to post-quantum crypto. So we're even looking ahead as far as that. It shows how this, we take a forward-looking view that our processors can go into the future. As far as the motor control, we have one addition is pulse width modulation. We have what we call high resolution, which allows us to get down to 195 picoseconds. So it's a very, very fine resolution PWM. That helps us with power efficiency and also the smooth control of the motor, so better driving experience with that. So it's integration of a lot of processing, a lot of analog, security, and the big thing on all of this, it's an ASIL-D device, so it provides the highest level of functional safety.
Now, one of the big trends we're going to be seeing in the automotive industry is a move away from IGBTs for the traction, the controls for the inverter, and a move towards wide bandgap, especially SiC and potentially even GaN. And one of the key elements of the efficiency improvement is then also to increase the switching frequency.
Exactly, exactly. And that's why this is forward-looking, because we already have customers moving to silicon carbide. And as you move to gallium nitride in the next few years, you'll need higher and higher switching rates. And that's one of the big motivations for this device, to get such a high level of performance that can scale into the future. OEMs want to invest in a platform that not only can bring them into the future, not just a one-off solution for one generation, or we see currently parts that are out there many times are parts that were designed for historical internal combustion engines. This was designed specifically for electric motor control and optimized for that. It has that support for those high switching. Now, the benefit of those the wide bandgap SiC and GaN is the ability to reduce the size of the components. The higher you go in speed, the smaller the components. We can shrink some very large capacitors and ultimately increase the power density of the motor and to decrease the size, which leads to less weight, which leads to farther range of a vehicle, which ultimately everyone wants to have. So really, yes, that's the key, to be able to support those, to make all those waterfall benefits fall out of it.
Now, the whole system requires power itself, the microcontroller, for example, and typically that's been outsourced in the automotive industry to something called a single system basis chip, yes, SBC. I understand there's also innovation happening there too.
Yeah, I'm glad you asked that, because this is not just about a microcontroller. We look at this as a solution based at multiple levels. So the first level of it is the combination of a very optimized SBC, which provides the power. You provide it up to 40 volts directly. It manages all the power rails to the MCU. It also provides the power sequencing. But the most important thing, I believe, beyond that is safety. Again, we want to have the highest level of safety, and so it has an isolated portion of the chip that provides very high level of ASIL-D support. So you have external monitoring. You also have dynamic communication directly with the processor, so it is aware of any types of faults. so there's that going on, and it has a support for standby mode, so it allows you to put this device in a low power standby mode, and it controls all of that. And then there's another part we can talk about that goes along with it, which are the gate drivers. So those three parts really are optimized to work together to provide the best power efficiency and the best overall system solution. But yeah, it starts with SBC. Our analog guys like to say, you can't have digital, or we bring digital to life, right? So.
And I think they're right.
Yeah.
Now, when it comes to motor control, the algorithms need some sort of feedback to determine the position of the motor in order to keep that commutation going that in the past was done mechanically. Resolvers are typically needed in that case, and you normally have a chip dedicated to that. Is that the case here?
Yeah, so that's one of those innovations of how we bring in some of those capabilities inside the chip with the analog integration, digital processing, DSP, et cetera. So we give our customers a lot of flexibility. So for in case of a resolver, that's a mechanical, like a transformer rotating around with the motor. We actually excited, that's one of the integration. We have a built-in sine wave generator. We generate the excitation, it generates a sine and cosine. We're able to bypass a chip, get rid of a chip off the board that's a resolver to digital converter, RDC. We bring that into the chip with the analog integration and our software, which is ASIL-D safe, and that's actually something that's new. Some people do software resolvers today, so that's not totally unique. It is a big important point that we can do, but we also take it to the next level for ASIL-D support. So that's really important. And what that gives us is a safe way to actually know exactly where the position of the rotor is of the motor, down to about 0.1 degree resolution. We think that's a leadership position, as well as the absolute velocity of that. And as you said, motor control is a feedback loop, and you have to continually update that control, and that gives us the exact position and speed that's really critical for us to have that high precision, the very power efficient motor control.
Now, in the past, the automotive industry has typically tackled challenges by having a function per box. They wanted to implement, say, a motor control solution for a window lifter, and we make a box to do that thing. But we're moving now towards this concept of software-defined vehicles.
Yes.
How does the solution here support that, and what can maybe the normal car owner expect from their vehicle over its lifetime in the future?
Yeah, that's a great thing, because yes, definitely software-defined vehicle. NXP is totally invested across that. As we introduced the SR2Z and E, those are the first processors, I believe, that were actually designed for a software-defined vehicle, where you totally isolate everything from the core all the way to the pin, and you could have multiple tier 1s and OEMs running on the same chip. They can't impact each other. They don't even know about each other. Well, we take some of those concepts forward. Also, we have isolation capabilities, so you can have multiple things running on it. But the key thing is, how do I take this to the next level for software-defined? I mean, software-defined is not just about downloading software and I'm good, I'm software-defined. It's not it always. It's a combination of how you develop for it, how you use the cloud. We support model-based design for this, so you can use the cloud for that. But a key thing that's really important is we have enough performance in this device that allows us to use those ARM processors to do data analytics, to trigger on specific events, like dynamic data collection in a smart way, to do some process edge. And if there's a condition, maybe there's some kind of anomaly, you can detect that and send data to the cloud. The beauty of doing that to the cloud is now you can capture for digital twins, for machine learning, and then you can adapt your algorithms, and then you can now use over-the-air update to update the functionality, and so the vehicle gets better over time. It gets more efficient, and you'll see incremental updates from the OEMs to give you longer range. Now, the key thing there, I call it, is a software-defined motor, right? It's the software-defined motor within the software-defined vehicle, and that is a totally new concept to be able to put all that together. So we have those three layers, basically, of having those three chips working together to provide future-proofing, high performance, high efficiency. Then you have the next layer with the S32Z or E working together to extend from 1, 2, 3, or 4 motors for better drivability, higher performance, and then you put this other layer on top with the cloud and the data and the intelligence to make it better over time to have a software-defined motor, and that's a powerful combination.
Well, I think it's absolutely fascinating to see this development here at Electronica. It's, I think we're really seeing the future of electric vehicles, and also that capability that we're going to see the automotive industry share with users and drivers and owners through the software-defined vehicle. So thanks, Brian, for taking the time to talk.
Thanks a lot, I appreciate it.
Now, the Electronica exhibition has always been about introducing new products to market, and that's no different here. This year, NXP has brought together the best of their LPC and Kinetis families to make the MCX series. I spoke to Romain to find out what their Series N family is all about. So hello there, Romain from NXP. We're here at the Electronica Exhibition 2022, and you are introducing a new series of microcontrollers. Could you give us a bit of an insight as to what MCX is?
Exactly. So MCX is the new MCU, so it is our brand new family that will be converging two major families in our microcontroller portfolio today, which are LPC and Kinetis. So they will converge together to one single family. It's MCX. MCX will be a very large family. It will be covered with 4 different product series. One of them is the MCX N, which is the most advanced one. There will be an MCX A, more positioned on the entry level that we call essential. There will be an MCX W targeting the wireless connected MCU, especially here on the BLE, but very compact and very efficient. And last but not least, the MCX L for ultra low power.
And so, then I was going to say the family is sort of a continuation of some of the best bits of the very popular and well-loved LPC and Kinetis controllers that you've had. What are the sort of the key pieces of those families that you're bringing into the MCX family?
Exactly. So we really have this chance today having Kinetis and LPC in our portfolio, because we can do some cherry picking and really select the best IPs that our customers have been really using for many years and bring them to the MCX. So the MCX N will have several IPs or peripherals coming from the LPC 5.5, for example, and many of them coming from the Kinetis world as well. So, for example, on the timer side, we have the Flex PWM timer coming from the Kinetis. We have the SC timer, the state control timer, which is also one big asset of a LPC today, coming to the MCX, and we will have both of them in the MCX together. So this is one example, but basically all this will also bring best migration capability for our customers. Today already using Kinetis or LPC, and together with the MCU Expresso, they will have a very efficient way to come to the MCX world.
So what have you selected as the processing unit for this family of devices? What's the central processor?
That's a good point. So for the sake of scalability and deploying such a large family, scalability is really one essential target that we have in the definition of this family. So one major aspect is the Cortex M33, right? We will have, even on the entry level essential MCX-A, we will have a Cortex M33, which will be on the smallest devices, a bare-bone Cortex M33. And we will have a dual-core Cortex M33 running with up to 150 MHz in the MCX N. So on all the 4 series, we will have Cortex M33 for the sake of scalability.
Now, the Series N is the family that's being launched at the moment here at Electronica 2022. Could you also take us through some of the other capabilities that are integrated into that microcontroller?
Correct. So we're starting the deployment with the MCX N. The MCX N is a very rich, very featured device. So beyond the 2 Cortex M33 cores, we are implementing some hardware accelerations. One of them is a DSP hardware acceleration, bringing really efficiency and additional CPU power to our customers with a lot of codic, mathematic functions already hardware implemented, but also with a full FFT implemented in this power quad. A major highlight, though, is the NPU, Neural Processing Unit. It's quite unique in this range of flash-based devices to have a hardware machine learning acceleration, we call the NPU here, which is bringing really a lot of benefits to customers looking after machine learning in their applications, with a, let's say, a factor 30 performance gap between same inference engine running on the core and running on the ML acceleration. So this is quite important. We have further hardware acceleration. We have a smart DMA acceleration, which enables, for example, the connection of a camera to the MCX N, but that enables a lot of other functions. See it as a core together with our DMA channels that is enabling a lot of new additional functionalities to the microcontroller. And we have a cool Flux DSP on top that will be enabled with some firmware like PLC in the first stage power line communication for a lot of metering customers that need to implement this. So it goes really beyond the M33, even the dual cores. We are really a whole bunch of hardware acceleration which are very differentiated and bringing value to the customers.
Now, another key aspect of microcontrollers is obviously interfacing with sensors, interfacing with other systems over connectivity like Ethernet. What's integrated into the M series with respect to communication?
So MCX N is also very rich on the connectivity side. We have a 100 megabit Ethernet MAC. We have a 2 CAN FD. We have 2 I3C connections. So sensors are moving. We see sensors moving always more to the I3C interface. CAN FD is establishing also as a standard on the industrial world. What's more is we have 10 instances of the FlexCom interface, meaning customers have a huge flexibility here in configuring the different FlexCom of the microcontroller into a SPI, a UART, an I2C, which is very valuable for them in their PCB design, right?
Mm-hmm. Super. So one last question then. When it comes to developing the software, obviously that's a big challenge. What does NXP offer in that space in terms of a development environment and maybe some first evaluation hardware to actually start programming the chip?
Yeah, so we leverage fully here the MCU Expresso. MCU Expresso is really our one-stop shop in terms of a software development tool. It embeds the IDE, so the integrated development environment, the SDK, the software development kit. Inside the SDK you have the library, you have the middleware, you have the BSPs. It embeds the configuration tool, so it helps configuring the clocks, the DME, the GPIO functionalities, and also where NXP is differentiated is we have a secure provisioning tool embedded directly on the MCU Expresso. It interfaces with GCC compiler, but it could support also further compilers available on the market. And it's already supporting Kinetis, LPC, I.MXRT, and now MCX. So it will be one major pillar of, let's say, the migration process for those customers who want to migrate from existing devices to the MCX. Furthermore, on the hardware side, we will have like a strategy with a standard EVK with all the features that you expect from an EVK. But in the very first months and during the early engagement, and also beyond that, we will leverage a so-called breakout board, which is very small, very cost-effective, very affordable, which will also bring a lot of connectivity aspects. So we will have a microbus connector, FlexIO connector. We are able to interface with the smart DMA. We have a PMOD connector. So small, but really enabling a lot of different connection capability for customers to build up their application.
Fantastic. Well, thank you ever so much for taking the time to take us through the MCX family, and we look forward to discussing with you some of the other series that will be coming out in the future.
Thank you very much.
Now, in order to make a lot of the applications that engineers create, we need sensors. And I've been here at TDK to find out what they've got. We've been looking at some 6-axis sensors for the automotive industry. There's also a fantastic robotics board with 8 different types of sensors on it, and motor control and a machine learning algorithm that can recognize voice commands. That's a great way, an easy way to get started with applications. But perhaps the thing that surprised me the most was the virtual reality headset, which is a laser-based system that projects directly onto the retina. So Fukuzawa-san, it's great pleasure to meet you here at the TDK stand for Electronica 2022. Now you've been busy developing something for augmented reality glasses. Could you tell us a bit more about this laser technology?
Okay, yeah, sure. Yeah, thank you very much for stopping by. So this is our laser module. So this laser module is the full color laser, 16.2 million color can be irradiated. And compared to the conventional full color laser module, so it is 10 times smaller, 10 times lighter, and it can be assembled with the frame of the glasses.
And so one of the worries people have about lasers is that they can damage their eyes. So what sort of power is going out in laser in this, because it projects onto the retina?
Yeah. So everybody asks such a kind of question, but for this kind of projection, so the laser power is only a few microwatt level, which means it's weaker than the fluorescent light. So it's quite safe, yeah.
Now we have a augmented reality laser output here, and in the side of here is the laser is built in, projecting it round a light guide essentially, and that should project the image onto my retina. Now I've not tried this out before, so I'm going to try it out now and share my experience with you. So as I bring it up closer, I should be able to see a, oh wow, that's incredible. So as I bring it up to my eye, all of a sudden I can see right in front of my, I can see beyond, I can still see the camera in front of me, I can see the other people here at the stand, but there in the middle of the frame it says TDK ultra small laser module, direct retina projection demonstration. And yeah, it's very clear, very sharp. There's also a picture of a drone there delivering a small box. And it's quite a nice experience because I think with VR glasses often you have that feeling that, yeah, you feel a bit dizzy and confused, trying to concentrate on things that are far away, but you're actually focusing up very, very closely. But this feels quite comfortable, and obviously this is just a demonstration currently, and would probably fit better with my glasses. I need glasses to see well on a normal day, so it's a little bit fuzzy beyond, but I can see how this would actually work as part of an augmented reality system. So very fascinating and a lovely experience. That's incredible. Now, what type of industries do you think would be able to use this type of virtual reality and augmented reality technology? What's your target?
So of course the consumer target for the augmented reality. So augmented reality means you can simultaneously see the real world through glass. But by using this technology, you can get the information on glass without adjusting your eye focus. So this is a great point.
Exactly. Fantastic. And is this a technology that is completed and can be bought by people, or is it still in development?
Still development. So this is the proof of concept. So it will take 2 more years for the production. But I think it's a good stage right now.
I absolutely agree. I've just tried it out. I think it's absolutely incredible.
Okay.
Fukuzawa-san, thank you very much for your time and taking us through this technology at the show.
Yeah, thank you very much for the interview. Thank you.
So hello Simone, nice to see you here at the TDK stand Elektor 2022. Now you've been busy developing some sensors for automotive that provide us some insights as to where the car is positioned and what the position are of, for example, doors. Can you give us a bit more background on those technologies?
Sure. The 6-axis automotive is a MEMS sensor which contains 3 gyroscopes and 3 accelerometers, one for each of the 3 axes, X, Y, and Z, of course. It can be positioned in the car to help the functionality of many ADAS modules such as LIDAR, radar, car navigation system, or it can be used for other features such as door control, or also anti-theft systems, all this kind of stuff. And its basic functionality is to provide information about the position of the car, how the car is positioned in space and how is it moving. Either it's accelerating, decelerating, rotating, and this information can be sent to a microcontroller. through either an SPI or an I2C interface, and can be processed to provide a lot of useful data for this system to work.
Now, in automotive, functional safety and safety in general is a very critical part. Is this something that's part of that safety system?
Sure. Okay. This very product is not for safety application, but nevertheless we have in development a product for up to ASIL B application, and we have a roadmap for increased ASIL levels for the future, because of course it's a very interesting and very useful features for the automotive products.
Now, one of the key things for engineers is getting started. What about evaluation boards and software?
Sure. As TDK Invensense, we provide a development kit that is a board which equips our 6-axis automotive sensor plus a microcontroller, and through registering on our website on the developer corners, you can download the software, graphical user interface, and the low-level drivers to operate with our product and develop your own application.
Well, thanks Simone for those updates and insights around the MEMS sensor. It sounds like a great technology for automotive, and hopefully we'll see it in some vehicles soon.
Thanks to you for visiting.
So you've been very busy developing a very universal board for robotics. Can you tell us a little bit more about the sensor technology that's been put into that?
Yes, so we have built this board, we call it RoboKit, and the idea is to introduce the TDK technology, sensor technology, into the robotics market. So we built this RoboKit board with multiple TDK sensors on it, like it has IMU, pressure sensor, temperature sensor, magnetometer, it has microphone, it has motor controllers, and it also has ultrasonic range sensors.
So the board itself can actually then function as a complete robot controller, is that correct?
Yes, that's right. You could build full robot using just that board. The board also has the battery connector, so you just connect the battery, you connect the motors with the wheels and chassis, you have the full robot.
So how many motors can I connect to this board?
You can connect 2 motors, like basically for 2 wheels you can connect.
And in terms of the ultrasound sensing, how many sensors am I able to attach?
You can connect up to 9 ultrasonic sensors. We have 9 connectors for the ultrasonic sensors.
Now, looking at the robot demonstration you have here, which I think is a really lovely solution, I also noticed that you've implemented some voice commands. How are they done?
Yes, so basically, as I mentioned, the board has the microphones on it, and it also has ARM M7 MCU. We have implemented machine learning algorithms which take the audio data and interpret the commands. As of now, in this particular implementation, it can detect 4 commands: go, left, right, and stop.
Fantastic. And what sort of applications do you think customers and engineers will want to be putting this type of technology into?
It can be used in robotic vacuum cleaners, service robots, and like many other robotics applications.
Now, robotics and robot systems, there's a trend at the minute to move towards the robot operating system, or ROS. Do you support integration with ROS systems?
Yes, that's a very good question. So basically what we did is, as I mentioned, it has ARM M7. If that is definitely for the bigger projects, that is not sufficient. So what we did is we implemented ROS drivers for all the sensors which are available on the board. And those ROS drivers can run on Raspberry Pi or any other Linux-based single board computer. So you can connect RoboKit board to the other boards like Raspberry Pi or NVIDIA Jetson, and run the ROS drivers on it and build your application on top of it.
Well, I think this is a really lovely application. It's nice to see so much technology in one place and it made so easy to use. So thank you for taking the time to explain it to us.
No, thanks for having me.
Now, starting a new electronics project is really, really exciting. You get to start up your schematic design software, PCB layout, look through the data sheets and get designing. But it's a long, weary process sometimes and take a long time before that first PCB is ready. I've been talking to Tobias from Celus here to find out how that can be really, really sped up and give you a board in as quick as 30 minutes. So hi Tobias, it's lovely to see you here at Electronica 2022 at the Celus stand. You were previously also part of the Elektor Fast Forward Awards a few years ago, so tell us a little bit about what Celus does and give us an introduction.
Sure, great to have you here, Stuart. Thank you very much. I'm Tobias, I'm one of the founders of Celus. And yes, indeed, we actually were at Elektor Fast Forward when Electronica happened last time, so 4 years ago now, quite a long time passed. And we at Celus, we offer a software solution for electronics engineers to design circuit boards in the fastest possible way. Basically, it is a design tool where they can go up in abstraction and describe the needed requirements of the system, and we automatically turn that into a component selection, a schematics, and a first prototype of a layout.
Is it interesting, so you were showing me the system earlier and you sort of compared it a little bit with software. So when we do hardware design, normally we sit down, we find components, we make a schematic and then we start working on a PCB, but in the software world we've increasingly moved to sort of a modeling approach where we describe in blocks what we want, and that's what we see with Celus, isn't it?
Yeah, that's to my mind the perfect analogy. If you think in the most extreme case in software development, at least, no code environments, website builders, what you're really doing is you're dragging around boxes defining the requirements. Everyone talks about how the website should look like. No one really has to think about what you need to do to make that box now red or green. And in the end, it's still source code being generated, it's machine code running over with CPU instructions somewhere in the cloud, but no one has to care. And that's the big difference to a circuit board design. If you want to design a board like this one, it's very different. You're on the lowest implementation level, you could say. An engineer has to make the decision of what component to use, even down to what resistor to put there and how do I connect that to my design. And that is like if the software world would write, not even assembler, but would write CPU instructions line by line. And if you would go now to a software team and tell them, hey, from tomorrow, you switch to developing only like that. They're gonna tell you, yeah, okay, then see you again in 100 years because that's how long our project will take now. And we somehow accepted that that is okay in electronics, and we think it's not. We think that especially with the increasing need, the increasing complexity of electronics, compared with, or combined with the slowing down, or basically less and less electronics engineers graduating, how do we bring these two things together? That can't work. And we see automation as not just the best way of doing that, but to be honest, the only way I can imagine of doing that. Otherwise, we won't be able to keep up with the demand and with what we need to do.
Now, engineers are notorious for sort of sticking with their traditions and also not letting go. We really want to know every last detail and everything. So give me an example. If I was, for example, wanting to develop a temperature sensor, how would I go about doing that in Celus? And I know the temperature range, I know how often I want to read it, it's got to be linked to a microcontroller. How does that look?
That's a great example, and I totally get it, by the way. Like, I've been there. I think that especially layout design is a ton of fun. But there is not necessarily the time for that. You could continue doing that forever and you would still find something, hey, if I now tweak this, it will be better. But we need to get away from that. And that's where we come out with you could say, a combined approach, where our automation makes decisions. It selects a temperature sensor for you, for example. It adds the needed components around. So for example, if that component needs a bypass capacitor, a certain connection to power supply, needs to have an I2C line to the microcontroller. We can make all of these decisions automatically, but the engineer is still in the driving seat, basically. So we still allow an engineer to modify all decisions that we made. They can still look at the list and say, but I prefer component number 17 more than what you ranked first. And we allow that to happen. And also at the very end of our process, we export in native ECAD format, so to Altum Designer, Autodesk Eagle, whatever you might want. And there, again, the engineer has full control. They can modify the designs, they can change everything. So they're still in control of their design. It's still their design. It's like running a marathon and you start at kilometer 30. There's still a marathon to run, but you're just a lot quicker at the finish line.
Now your tool also does auto routing. It can actually generate a complete circuit board. Is that something that I could actually take then into production, or is this more for accelerating the prototyping process?
So that's a good question right there, because if you look at, for example, that board there, that is 100% automated straight from our software. From requirement to what I'm having in my hands was around about half an hour of engineering effort. But that's very key part is who is focusing on what. And we really see that engineers should focus on what is most complex, and automation should take the manual repetitive part away from that. And we at Celus, we drive first and foremost into automating schematics and component selection and master that. And layout is mostly exporting to the ECAD systems, provide a good floor planning proposal, provide a functional, fully routed prototype, but it's just that, it's a prototype. It's still the engineer then in command, in finalizing it, in optimizing it, and really making it a stellar product, and that then goes to production.
Now, is your solution a type of software package that I download onto my PC, or does it work differently to that?
We are 100% cloud-based, so it's completely runs in the browser. You go to our platform, log in, get into your named user account, and you have everything around you. Can also collaborate with your team and your entire company actually over our platform. Can access a larger library that is shared, and also even a big part that we're aiming for the beginning of next year is launching a community edition. So stay tuned for that. And there it's literally going to the page, logging in, creating an account, and start playing with it. We make it as easy as possible.
Well, thanks ever so much for taking the time to talk to us at Elektor. I think this is a really incredible platform for development, and can really see how it can speed up that prototyping process. And it's great to see where you've come over the last 4 years since we last had you with us on the show.
Thank you very much. It was a pleasure talking to you.
2 years into the COVID crisis, and we still have lots of semiconductor supply chain issues. I stopped here to talk to Paul Romano from Fusion to find out how they're helping their customers fill that gap.
So my name is Paul Romano. I'm COO and head of all quality for Fusion. So Fusion is one of the world's largest open market distributors. And our role is to support our customers in a number of different ways. So principally, we solve problems when they can't get the parts from their normal sources. We essentially fill those gaps for our customers. If we think about what's happened the last 18 months, we're right in the middle of that, providing parts to our customers so they can keep their lines running and get their products to their customers. So we really have a very significant part in the supply chain. In fact, we see ourselves as the critical link in the supply chain, because when nobody else can do it, Fusion can.
Now, the supply chain has been a massive issue over the last 24 months since COVID, and I think one of the challenges people face is, I've seen people on Twitter saying, like, can you just send me some parts? If you've got 10 of these, could you send them to me? And obviously you don't know what you're going to get from that person, and most people don't have any real way of, other than using it, to check its quality. So what is it that you're doing to prove that those parts are really genuine?
So quality is one of the foundations of Fusion, and obviously for our customers, quality is paramount. So we have a significant inspection and testing protocol, but we go even further. A lot of companies, and Fusion included, were outsourcing electrical tests. And one of the unforeseen outcomes of the shortage was there were a lot of new players that came into the market sourcing parts, and everybody wanted everything tested. And so there's a finite number of test houses. So lead times at test houses skyrocketed from 2 weeks to 5 weeks to, in some cases, 8+ weeks. We were doing everything we could. We used a number of test houses to try and spread our work out. We paid for overtime, but in the end, none of it was helping. So to solve the problem, and Fusion believes in always solving problems, we acquired our own test house. In February of 2022, we closed on the acquisition of ProSemi, Singapore's largest test house. That now gives us significant electrical test capability. It gives us services, baking, tape and reeling, and IC programming. It gives us significant extra analytical capabilities, scanning electron microscopy, EDX, Fourier transform infrared spectroscopy, cross-sectioning. So ProSemi has really allowed Fusion now to be a true end-to-end solution for our customers. We can source, buy, inspect and run through our labs, and then send to ProSemi, who Fusion owns, and have testing and further analysis done, provide a report to our customers to ensure that everything is as it's supposed to be. And that's what Fusion guarantees, quality.
So you were saying that the time for that testing process had got up to around 7 to 8 weeks. What have you managed to bring it down to through this new acquisition?
So the acquisition of ProSemi allowed us to do a couple of things. First of all, it allowed us to get a lot of additional data. So we were able to take all of ProSemi's die data, all of ProSemi's inspection data, and add it to our own. We now have the largest die database, we believe, in the industry. And we also have one of the largest databases of inspections and digital photographs of devices in the industry. So we've been able to do that. We got the people, but the key thing is, because what goes through ProSemi is directed by Fusion, we've been able to bring the lead time down of that testing from 8+ weeks to, in many cases, just 2 to 10 days. So it's a significant advantage to our customers, and our customers really appreciate being able to get the parts more quickly, know that they're as they should be able to get them into their products so they can ship to their customers.
Now obviously you're not manufacturing these chips, the chips
nope.
that come in and are manufactured by the well-known names in the semiconductor industry. Where do you get your data from? How can you be sure that genuine part is genuine? And I guess you must need relationships with these semiconductor vendors.
So we use a number of different avenues. Obviously, we have a lot of internal knowledge, and our inspection process is extraordinarily detailed. We have internal labs at all of our facilities that allow us to do XRF, X-ray, chemical decapsulation, heated chemical test, solderability. Now with ProSemi, we can do even more. Electrical tests, SEM-EDX, FTIR. So we're able through all of that to really determine that these parts are in fact what they're supposed to be. What we have done though at Fusion, one of the second large improvements we made is we've built our own engineering department. And we've gone out and we've assembled a team of engineers from some of the largest semiconductor manufacturers in the world. We have 2 engineers from TI, we have a Cypress engineer, an ST Micro engineer, a Broadcom engineer, and they really work both internally and externally. They're a resource for us because they help aid in our inspection process and help inspectors understand what they're seeing and what, they help them work through findings that they have, as well as they support our customers. And they support our customers by providing information, data, being a resource. What Fusion wants is Fusion wants our engineers talking to our customers' engineers so that we can better understand their requirements and implement and fulfill them. So we have 20 degreed engineers in the company. We have 7 with direct OCM experience. We also have a test engineer who has experience from Analog Device, TDK, Skyworks, and Connexit, and she really helps design both software and hardware so we can do additional testing.
Now if you look at some research that's going on in the scientific community, I've seen presentations on fake parts.
Mm-hmm.
How many fake parts do you feel are really out there through the material that comes through Fusion?
So, we've done a lot of work to really develop our vendor management system, so we don't see a lot. We do see some, but we don't see a lot. And it's really all about understanding who you're buying from, and having great knowledge and controls of your vendor base. And we've developed that kind of a system. And that's allowed us to really crank down on what's coming in. So it makes the inspectors' jobs easier, but they still have to do every job, every step of the way. But it's really about having very strong control of your vendor base and knowing, what they're providing, where they're getting their parts, what they're doing to ensure the parts are not counterfeit. We want to work with vendors who have sources that are direct, authorized. That's what we're trying to do. So we know that when the part comes into us, it's 100% authentic. That's the critical piece. So we don't seal it.
Well, thanks ever so much for providing us the background on how those sourcing challenges are plugged, and it was great to meet you here, Paul.
It was great to meet you. Thank you so much.
The last stop on my tour around the halls of Electronica was to see Hafiz Khalid from XP Power. Historically, the group is known for its expertise in low voltage power supplies. However, since 2015, they have invested heavily in high voltage, making several key acquisitions. I asked him how their portfolio has broadened and what new applications they can now support.
Yes, as you said, XP Power has been a very established name globally for low voltage power supplies in healthcare, industrial and semiconductor applications. And over the past 7 years, we have been on this journey to address these customer applications in the industries that I just mentioned. So for past, we're trying to bring that to life a little bit for our customers and for our audience on this trade show, and then bringing our high voltage journey to life.
So with the high voltage products, what sort of voltage range and power range are we talking about, and what are the key applications that are using them, the key markets and customers?
So for high voltage, for anywhere like from a few hundred volts up to 500 kilovolts. So the range is pretty significant, pretty wide. And then in terms of power range, it's also like anywhere from like half a watt up to 600 kilowatt. Now with this recent acquisition, we can go up to 600 kilowatt. And as I mentioned earlier, our focus is the same in terms of industries. We're still basically, again, focusing on semiconductor manufacturing applications and industrial technology applications and healthcare application. But with these acquisitions, again, we're moving into more precision with the latest acquisition of FUG and Guth, which we're highlighting on this trade show as well. We are able to move into very highly accurate and precision applications, and the scale of that precision is down to like 1 ppm type applications. So the application like scanning electron microscope, mass spectrometry in industrial market segment, and then in semiconductor, where you need to actually inspect the wafer, that as you know, that has also been moving to like nanometer scale. So once that's done, the inspection part of it requires very high accuracy as well. So that's where these accurate high voltage power supplies come into play.
Now you've also been showing a brand new power supply product here at Electronica 2020. Tell us a little bit more about the Series FT.
Yeah, so that's, we have this very exciting release, FT series, which is also, again, the same story, trying to address more of the applications from our customers in semiconductor and high power e-beam industrial applications. So as the semiconductor technology is evolving, the requirement for bringing more functionality, more voltage, more power into small size has been very significant from our customers. So this product actually delivers that voltage which would usually be available in a 2U rack space. So this basically brings it down to 1U rack space. And the voltages still can go up to 60,000 volts in 750 watt. So this is very exciting for us.
And one of the interesting things about power is there's lots of companies out there which have a standardized portfolio. There's others that focus more on the custom side. You come with your requirements and we'll fulfill your needs. Where does XP Power sit in terms of customizable solutions and standard solutions?
That's a very good question. So Yes, XP Power, more than 50% of our revenue comes from modified and custom products. And again, all the applications that were mentioned earlier, I mean, the customer do require some modification based on the exact requirement and based on the exact application and what they're trying to do. So again, all these products have the standard capabilities set, but beyond that, it's a conversation that we have with our customers, and as we do modification and customization required. And as I said earlier, I mean, this new acquisitions, FUG and Goose, they just take that customization to a very next level. I mean, we can customize anywhere from like a capacitor charger, a high voltage power supply, to a very, very big system for high power E-beam applications, E-beam welding type applications as well.
Well, thanks for giving us an update on what's going on at XP Power, but especially with the high voltage and the tight integration with the semiconductor manufacturing industry. It's very relevant for Electronica 2022. Thanks for your time, and we look forward to catching up again soon.
Thank you so much. Thank you, Stuart, for your time as well and visiting us on the booth. Thank you.
Well, that's all we have time for on this edition of Elektor Engineering Insights. I hope you enjoyed our review of the Electronica 2022 exhibition. Please subscribe to Elektor TV on YouTube and feel free to share this video with anyone you think that might be interested. And if you want to know what's coming up on future shows, take a look at electormagazine.com/Elektor Engineering Insights. If you'd like to join me as a guest or share some technological advancement that you've been working on with the engineering community, feel free to drop me a line, get in touch however you wish to on Twitter, or connect with me on LinkedIn. Thanks for joining us today, stay in touch, and don't forget to keep asking your engineering questions.